What we are going to present is a work that is part of a PNR project that is about how to use place pulse data set for evaluating urban perception. In particular, what we would like to achieve is to understand which is the best machine learning pipeline for predicting human perception based on the place pulse data set. But during the research, we noticed that there are some limitations about this data set. The first one is that the data set is unbalanced among the 6 variables of perception that it can assess. And specifically, there are some classes that are over represented, and this can create biases in the results. Second, in the literature, there are limited performance tests on a small number of training algorithms. So the point is that, and especially there are a few tests about advanced solutions for running the machine learning process. And also the different configuration of the pipeline hasn't been studied in an advanced way, let's say. So we propose some solution in order to validate itself first, and especially in the presentation, we are going to explain how we test different machine learning pipeline configuration in order to get to more reliable results. And then the idea is to try to reduce of the tool. Pulse is a data set that was developed at MIT with a crowdsourcing campaign in which people were asked to answer in a comparative way. They were shown 2 different images from Google, and people have to evaluate those images based on safety, livability, boredom, wealthy, depression, and beauty, which are actually the 6 variables that the tool now can access. And it was amazing. It is very important because it was amazing the number of people that actually participate into this survey. So it has more than 81K participants. In the previous studies that we presented formally, we did a former study based on the usage of different images. One is, of course, an image with the size of the image used by the original place pulse campaign, which is 90 degree by 67 by 5 degree, and other images that are more near to the field of view of humans, which is, in the case of our study, 160 degrees by 120 degrees. And also not considering the very peripheral view. So in that case, we demonstrate that actually considering or using a different image as a base produce different outcomes in terms of prediction, perceptual prediction. But this was for the first step, let's say. Now what we are evaluating is how different machine learning algorithms can also affect the trustability, the accuracy of results. And this is what we are going to show.
Okay, our method is organized in 3 main steps. The first step was to balance the differences in the representative of each of the 6 variables. Then we applied an image segmentation onto the picture set of place pulse to connect the urban features obtained by from the pictures with the perception variables. Then the second step was to compare the 4 different algorithms using the T-spot framework for identifying the best option among them. The third step implied to compare the best option that we are going to see which one is with more traditional algorithms such as k-nearest. So now the first step, then we extracted the picture by place pulse dataset, identified the amount of features in the pictures, and used this information as features data for the training. Then we considered this perception scores of the dataset as target for the training. Then, on using the image segmentation as input, we analyzed it in the three-pod framework, the four algorithms, namely the ElasticNet, REAACH Lasso, and XGB regressor, finding that the best one, the most efficient, is the XGB regressor. And we validated the result, the prediction of the XGB regressor, comparing the prediction with the actual result, the actual scores of the original dataset. Then the next step, in the next step, we wanted to compare the best option, XGB boost, with more traditional algorithms that are used in previous publications, such as random forest and k-nearest. And we discovered that also in this case, the XG boost is much more efficient compared on all the six perception variables compared to the other algorithms. The case study we used to as a new set of images is the Bovisa neighborhood that is a district in the north of Milan that is involved in an important urban renovation process. Here you can see a possible path that we consider that starts from the Bovisa train station and crosses a parking area, then face a building site and reaches the Bovisa campus as last point. In all these 5 points, we shoot panoramic pictures, and then we selected from the panoramic picture a representative view, and that is framed exactly with the same size of the original place pulse to images dataset. Here you can see the picture represented that represent the points along the path. The first one is the train station. The second one is the car ramp next to the train station that looks toward the parking, a huge parking area. Then we have the Bovisaska street, the building site, the fourth one, and the last one is the Bovisa campus. So comparing the outcomes of 3 different algorithms, the XGB, the k-nearest, the random forest, we can see that the 6 different variables, perception variables, performs very differently with these 3 algorithms. So in some cases, XGB generates a lower result, while with other variables, XGB rises a higher level, a higher intensity in perception. These differences are not constant along the path. We can see that the lower and the higher levels are changed across the different perception variables, and this is due to the fact that the different algorithms react differently to the imagery and to the urban features. Then we wanted to assess how the different points performs in terms of perception variables along the path. And as you can see, the first point next to the train station is the lower in terms of livability, while The last one that is characterized by, for instance, this long wall painted, all painted, covered with graffiti, is perceived as the most beautiful point of the path.
So to conclude, we showed that it is really important to choose the proper model and the proper process in order to get to robust predictions based on place paths. And of course, our test, which is a first test that should be repeated in other types of morphology, for instance, so far shows that the best pipeline is the XGB boost, and that and this is due to the fact that it is the tool that produce outcomes that are more closely matching the original impressions of people if we apply this to the original images. But we think that this is not enough to conclude this research. So the next step we are going to improve and to develop is a comparison between the prediction using place paths, which is in any case an interesting tool, with prediction based on a methodology we develop, which is a patented methodology developed together with Statale University and together with environmental psychologists, that enable us to do an assessment on different psychological variables of the experience of people in places. So the next chapter, let's say, of the research is to compare the prediction using machine learning and the assessment with real people in the real environment, and to check if the prediction are coherent or not, and in case, in which type of variables and which type of variables can be considered, let's say, accurate, and if there are some variables that are maybe need another fine-tuning, let's say. Thank you.